everyone, and welcome back to another episode on the Silicon Dreams 1550 AM. This is your host, Sharlaine, and today's guest is somebody special, Zach, a PhD student at the University of Mississippi who merges AI, computer vision, and remote sensing to develop decision support systems for railway ground hazard mitigation. I mean, how cool is that, right? Welcome, Zach. We are, extremely happy to have you on our show.
Thank you to all your listeners out there. I'm happy to be here to try to talk about this project we're working on. Thanks.
Absolutely. We're so
Yeah.
glad to have you. So, now that we've heard a little bit about you, we're definitely excited to hear more about your journey. What got you into AI, computer vision, and remote sensing? What has your journey been like from the start? Was this something that you always wanted to do, or this is something that came along the way? Please go ahead.
Yeah. So well, so far I would say my journey has been a bit some sort of pre-planning and just always trying to push myself to go further to know more about stuff that I just find fascinating.
Mhm.
Um, So my undergrad, I did geology engineering in Ghana,
Mhm.
and for geology engineering, we're looking at mostly rock mechanics, like those kind of stuff. Then for my master's, it was actually in civil engineering, and once more, that was the time I actually got to use LiDAR for the first time. So
Okay.
the first LiDAR that I got to use, I was just amazed. You just have this device where you kind of put it in in, to kind of just it was just it's this kind of feeling where you get to use something for the first time,
Yeah.
then you see the results and you just like, how did they do it? Like,
Yeah.
why does it work? So I was pretty much just in love, let me put it that way, in love with the whole idea of using LiDAR stuff for like for remote sensing.
Mhm.
So once I was done with my master's, even before I actually finished my master's, I started reaching out to professors that were kind of doing research in relation to remote sensing. So that's how I met my current advisor, Dr. Thomas Umain, and from there it has been a nice journey. So once I started my PhD in computational science and engineering, I quickly switched to, once I started my PhD in geological, I quickly switched to computational side because I
Mhm.
was more interested in actually building models that could approximate real world occurrences. So I tried using a whole lot of machine learning,
Mhm.
but the vision side, I was more attracted to the vision side of things. So
Right.
over the past year, I've kind of most of the models I actually developed, I try to stick with the vision side of stuff.
Mhm.
Um, then my advisor, he had an opportunity to move to University of Mississippi.
Mhm.
So in our switch, I decided to just go full, just try to switch to computer science now.
Mhm.
So my journey has been an amazing one. Let me put it that way. I've gotten a chance to learn a whole lot of stuff from people, and it's just I'm grateful. I'm grateful for where I am today. Yeah.
That is, I mean, that's a wonderful journey. And, we and the listeners, of course, are excited to hear more about what you do and why you do what you do. So getting a little into, the whole concept of AI and remote sensing data. If you could explain how AI is actually being used for remote sensing data for railway ground hazard mitigation, especially, and, are there any specific AI algorithms that are particularly useful in this application that you could educate our audience about?
All right. So when you look at a whole lot of remote sensor data, it tends to be very highly dense data. And very dense in such a way that usually you have it either at very high resolutions.
Mhm.
So when you look at the amounts of data you're taking per minute, it could be running to gigs, like gigabytes. So you need a way to kind of analyze this data
Mhm.
in a much more automated way than actually derive features from this mostly science data. So
Right.
that's where machine learning comes in. With
Mhm.
machine learning, there are a lot of techniques out there that you could use to derive a set of features that you could train a model on.
Mm-hmm.
So I would say it's a natural occurrence where you have a whole lot of data. A lot of people go for machine learning because it just fits what needs to be done.
Mm-hmm.
And especially now that there's a whole lot of push for computer vision stuff.
Yeah.
So people use the classical computer vision methods. We can't do without those methods. But deep learning is playing a bigger role now in
Mm-hmm.
most of these models, especially when you look at automation and robotics. Now, when we look at disaster management, geohazards, hazards of the such,
Yeah.
there is a whole lot of data that we can collect. Some of them tends to be from satellites, optical, thermal, um, interferograms. Interferograms are just like some of what we use a lot in terms of looking at how much changes occurs on the ground. So you're looking at subsidence, rock slides, and such. So now, when you have such data,
Mm-hmm.
you can use techniques such as PS insert. So the PS is what they call persistent scatter, interferogram static aperture radar.
Mm-hmm.
So with that technique, what you're essentially doing is you stack a set of interferograms,
Okay.
then you find that in each image there are some pixels that are very persistent.
Okay.
So across time, you can note how these pixels are changing, and you can use that to determine the velocity of motion at a particular point. So
Okay.
which you can look at it even to a millimeter scale, how much changes are occurring on the ground.
Mm-hmm.
Now, the US right now hasn't had a whole lot of federal kind of where they try to build one, not build one per se, but just try to have one common platform where they could try to inspect or monitor all critical infrastructure in the US,
Mm-hmm.
but that is in the pipeline now. So
Okay.
right now, NASA with the Indian Space Agency, the, once the new satellites that are going to be out there soon, they're looking at doing that. So with the PSSR, there are a whole lot of algorithms
Mm-hmm.
that kind of use machine learning methods for that as well.
Okay.
Another one is the what we call the small baseline SBAS.
Mm-hmm.
Now, that is at a high resolution scale. Most of these stuff tends to be at 30 meters, 20 meters, 50 meters. Now, at such resolutions, they are useful if you are looking at something like a dam, um, critical infrastructure that of large size. But if you look at the rail itself, the rail is basically just two metal pieces with a whole lot of complex environments that they pass through. And those ones, if you look at the gauge of a rail, is about 1.435, they're about like a standard gauge. So it's not a very wide
Mm-hmm.
equip infrastructure that you can essentially use Pearson cell.
Yeah.
So what tends to happen is you have to look at a more high resolution. So you'll be looking at UAVs and
Mm-hmm.
even on the ground monitoring equipment that you can have.
Mm-hmm.
Now, some of these techniques tends to basically use high um, like very sensitive sensors to measure the displacement that actually occurs. So something like the geometry of the track itself.
Mm-hmm.
You have a whole lot of data that are coming from this, and
Yeah.
also now that there is a push to use UAVs as well to monitor areas that are very highly sensitive, like areas that in the past have failed. You can easily take temporal data sets. So on a weekly basis, monthly basis, you go out there and see what happens. Now with these, you can easily build defect detection systems. So you see a lot of manufacturing occurs where they kind of use computer vision to see how many of the products that they actually build are defective. So you can apply such vision models to trucks as well. So for
Okay.
trucks, it could be used for actual motion of
Mm-hmm.
the rail itself or finding spots that tend to be problematic. That's if you can get enough data to actually do that. So our group, we are pushing for more of our real partners to give us the data that
Okay.
we can build. We do have first generation models for a whole of this.
Mm-hmm.
Other universities and groups have done some as well. And it's just that we need more data to actually fine tune and continuously, make these models better. Another one is change detection. So with that, at the same time, when we come look at the scale of a whole of these UAVs images, you could build. We do have one now. We are writing a paper on it. It's basically a combination of it's a hybrid model. That's we use deep learning methods and the Pascal change detection methods that are in computer vision. So when you combine these two, you
Yeah.
have a model that represents the past and the future put together. And the
Okay.
reason why we do that is for the real industry,
Mhm,
they favor models that are fast
mhm.
and cheap to use.
What are the, the hot areas right now that AI and computer sensing could be used in, and the future application as well?
Are we looking at in the real industry or just general
Just
in the
generally
industry?
things as, yeah, generally any industry.
Mm. I think to me, one area I would love to see more of, and I think a whole lot of people are working on that, is in agriculture and climate change. I think these two areas, if we could have a whole lot of research and
Right.
actually applications of these, we could help, solve. Eh, I mean, well, hunger. There are still people out there that's hunger is still something that's a big problem. And then when we come to climate change, I've not given up on humans, I believe there is a group of people that's with the right tool sets, they could find a way to mitigate climate change on a very global scale. So
Yeah,
we may still have flare-ups here and there due to climate change, but maybe it would be a managed risk, not just something we hope for the best.
that's true.
Another thing is just automation. Like if you look at a whole lot of automation stuff, um, someone told me that the robots are here and they're getting better. And it's true. If you look at Boston Dynamics and a whole lot of Chinese companies out there that I do not want to state their names for obvious reasons,
Yeah.
but they are doing a whole lot of work using um, robotics. So it's something that's I, I also love, but right now robots are just too expensive. I would love to see, you know, um, companies that kind of produce parts of these robots and
Mhm.
make it easy for you people to build their own robots.
Mhm.
I think it's just there are a lot of innovations that can occur in research groups and even just individual people just you know
Mhm.
tinkering with robots. So
Yeah.
I would love to see a whole lot more on that. But
Right.
one thing is like when it comes to automation stuff, is like there's always this problem of people could lose their jobs and all that.
Yeah.
It's just that it's a natural progression of stuff. Things will always actually be improved.
Mhm.
So you look at most of what's is done in tech is generally a natural progression of trying to improve upon things.
Yeah.
So I'm not going to say it's all a sham. Like when it comes to the recent developments and hype in AI, but looking at the applications of some of those stuff, especially when we look at robotics and a whole lot of agriculture and climate change, I
Mhm.
think there are areas that I believe could benefit a lot
Right.
as well. For robotics, we are looking at from manufacturing to healthcare to logistics. It just cuts across a whole lot of areas that automation could be used.
Yeah, that is true. I mean, a lot of people actually do talk about AI. I mean, the whole world actually about AI taking over their jobs. And,
Yeah.
for me, sometimes as a content writer, I wonder, will it ever? But then I realize that for now, at least, wherein you never know what the potential of AI is in the near future. Because who knew today that Chat GPT would be something that we would
Yep.
be
Yeah.
using? But yeah, right now I think it's helping us work smarter. It's helping us figure out a lot of things. And I think, like you said about optimizing clean energy, for example, if that's something AI could
Yeah. Yep.
help manage, renewable energy, sustainable practices, waste reduction,
Yep.
for that's affecting climate change, right? So I
Yep.
think
Yeah.
if we use AI for good, it's like the internet, right? Like social media.
Yeah.
You could use it for the good thing or the bad thing. It's
Or
all
the bad. Yeah, that's
Yeah,
true.
it's all up to us. So like you spoke a lot about robots and the use of AI. If you could tell us, what is something that you are currently very, very passionate about, even besides the railway thing in AI, that is very, that our listeners could probably take back and say, okay, this is something that I can do.
All right. Um, so right now, there are a whole lot of models out there that kind of look at classical machine learning or computer vision tasks.
Mhm.
Um, I've seen people that's build stuff. They just, you know, get their own data and just build stuff that actually works.
Mhm.
It's something that I wish we had more people that could do that, but it's getting expensive to actually build very good models.
Mhm.
And with the robotic stuff, I mean, it's if you look at Boston Dynamics, I think that they are robots. The prices tend to be around 60,000 thereabouts for just a robot.
Yeah,
That's still very pricey.
yeah,
Um, I don't know whether your viewers can see this. So this car that we have behind us is just something that's someone here is working on.
okay,
I mean, it would be nice if he could we could work on something much better.
yeah,
But because robots are so pricey, you just use what we can get. So something like this is he has to still, customize the code and all that using Rust 2 and stuff. But
right.
it would be nice if we could actually afford robots that can do more. But instead of us using a race car that we have to build the code from the ground up. So it's when I spoke to him, he's just a colleague of mine here. He he also loves robotics. It's just that as an institution,
Mhm.
they look at trying to spend $60,000 on just one robot
Yeah,
when they could, buy a whole lot of stuff that are at a cheaper scale.
yeah,
It makes sense as an institution, just looking at the costs for
right.
this one. So yeah, I would say I would love to see robots parts become much cheaper and
Yeah.
also much more customization. I do understand as a company they always want to protect their source code, but I would love to see the source code.
Yeah.
I would
No,
like to see it, see how it works. But yeah, open source. I think
yeah.
yeah, if more people could go open source on the whole of stuff that they are building, not
Mhm.
as a company, but just as an individual, share more stuff. It's just cool. It's just I think knowledge, when we share more knowledge, make it more
Mhm.
accessible. Everyone gets better at it.
Right.
I mean, a whole lot of research work that we do here, even though initially we try to not share it because of our partners, their
Mm.
data may be sensitive. But once we find a way to protect their data, we try to share most of what we do in conferences and reports that we write to the FRA that are freely available to anyone that wants to read on them. So
For our final question, what is the one piece of advice you would give to aspiring researchers or youngsters working, or even if it's the older generation, it's fine. Anybody working in the field of AI or pursuing their career in AI for the better.
there are so many developments
Mhm.
that's comes around that's it's very difficult for you to keep track of. But if you have a stable and a very thorough understanding of what's the basics are, it
Mhm.
makes it easier to easily catch up when you want to kind of look at a particular area.
Yeah.
So it's very difficult for someone to make a switch from
Yeah.
computer vision and suddenly become very good in NLP.
Mhm.
Usually you may have a fair idea of what NLP does, uh, what are the foundational models there, how the foundational models were built, and probably that's all. Probably you have never even worked on any NLP problem in your life. But because you have the basic understanding of what neural networks are, the type of neural networks that are out there, and how, you know, stuff like back propagation and stuff, it just gives you a much firm standing to grasp, to learn more on a particular thing. I still do that. I try to always go back and read more, like blogs, and even follow people that I know that are very good in what they do. I follow them, and even papers. I tend to read papers. I don't understand all the papers. So what do? I go on YouTube and see people that are much better than I am.
Mhm.
Andrej Kapati, there are a whole lot of people out there on YouTube that they are
Yeah.
very good in what they do. They are much more let me say experts than me, because
Yeah.
they have actually built these systems. So you follow them, see the papers they read, you probably read those papers and you then grasp all the concepts in there.
Mhm.
You watch one or two videos, so you may not grasp it,
Mhm.
but the key thing is you made the attempts and you keep on working more on it. So
Right.
with time, it just comes naturally that, well, they spoke about life. So life is 2D to 3D. So how does spline or computer vision, how does it go with that? So you start to make connections here and there, and you see that it's like someone is building a let me put it that way. It's like someone is building a a house,
Yeah.
and you are just a builder. So
Mhm.
at any point in time, you do not have the entire knowledge of how everything works, but you have
Yeah.
a fair idea of how the house is built.
Right.
So that's one thing I would encourage people to do. And
Absolutely.
also, you have to always stay up to date. It's very difficult to do that. I
Mhm.
went for a GRC conference.
Mhm.
After the GRC conference,
Mhm.
I'm like personally, I have to try and go through all the papers and presentations that people had there. Now that's applications of, that's real stuff. And
Yeah.
people spoke a whole lot about application,
Mhm.
things that I would like to know just within the railroad industry. At the
Yeah.
same time, there's CVPR. I
Mhm.
would love to see what people are doing in
Mhm.
relation to um building efficient models.
Mhm.
It's something that I need to kind of have a very good understanding so that I can apply to the railroad industry. We are
Mhm.
trying to save money. We're not trying to build models that are too expensive to even train. So I'll have to go and look at what people said in CVPR and see how I can use it when I train my next model. So it's like you have to always uh
Complete
is
the
it
whole. Yeah.
yeah, you have to continuously stay
That's
up
true.
to date to what
Yeah.
is happening and see how you can apply that in whatever you want to do.
Ab-
So for anyone out there that wants to, get involved,
Mhm.
learn the basics, keep on learning the basics and keep on relearning the basics and stay up to date.
Absolutely. I think we've definitely taken that advice. Our listeners sure have. So learn the basics, relearn the basics,
Yep.
educate yourself, learn from. I mean, there's so much of, material available online. And like you said, there are people who are always better than us, and there's so much we can learn from them. Take that down, make our corrections to what we are currently doing, and stay up to date for sure. I think in technology, that's like the mantra to stay up to date with everything because it's
Yeah.
changing every second.
It's a whole lot. It
Yeah.
just
It's crazy. I know
sometimes
people. Yeah.
I just look at a few papers and I'm like, well, if I'm going to read all these papers,
Yeah.
at the end of the day, will I still get paid for what I'm supposed to be working on? So sometimes it's more like I just look at the paper, see their conclusions, see their like the techniques.
Hmm.
Then if I don't understand some things, I try to Google it or just watch people's analysis of the papers.
Right.
Yeah, there are very good people out there that do a very good job in analyzing these papers. So
Yeah. That's
especially if you are a more visual, like
Mhm.
I know some people they tend to not like reading, so watching videos
Yeah.
also helps. So yeah,
Yeah.
it's good. It's good to have multiple sources for some of these
That's
things.
true. Yeah. Multiple and reliable sources for sure.
Reliable. Yep. Yeah. Yeah.
So
YouTube has a whole lot of Oh man. Yeah, I've seen some videos on ML, especially computer vision stuff that it just
Yeah,
doesn't make sense. But I'm not in the position to rebuke people who are trying to just do good.
yeah.
Um, but it's yeah, you have to find reliable sources on it.
Absolutely. Yeah, I think that's how it is. Yeah. So you take in the knowledge and then you segregate what you think is, important and required and reliable at the end of the day.
Yeah.
So yeah, I think that was a very interesting conversation and interview, Zach. Thank you so much for sharing your insights and being on our show, taking the time from your busy schedule to being on our show. It was sure an enlightening interview, and especially for our listeners. Thank you so much for coming in today.
Thanks for having me, and I hope to get to talk more about the stuff. Maybe on
Absolutely.
the next session. Yeah.
Absolutely. Yeah, for sure.
Um, for
Yeah.
those who want a much more engaging, more technical stuff, I hope maybe we could have a session like that where we try to look at the more technical stuff in computer vision as well. That'll be a very good,
Yes, for sure. We're going to be tagging
focus
you
as well.
in our posts as well. So, you guys can go follow Zach and, reach out to him if that's fine. If you guys are working on something similar. Yeah,
Yep,
that
sure.
would.
I'm always looking to engage more with people.
Mm-hmm.
On LinkedIn, just
Yeah,
click the connect. I'm always ready to connect with people,
awesome. You
and
guys
learn
can
more.
connect
I
with
follow a whole
Zach
lot of people,
on.
so yeah,
Yeah.
let's connect.
Great. All right. That's very generous. So yes, you guys, if you guys are listening today, you can connect with Zach on LinkedIn, and he will enlighten you just as he did with us today. So to all our listeners, thank you for tuning into the Silicon Dream. Stay curious, keep exploring, and join us next time for more fascinating conversations with leading innovators.